Day. My name is Hanan. I'm taking care of marketing communication for the IMEA region. I'm very pleased to meet you today and introduce you to our very beautiful team. So today we're going to go through a main webinar about our capabilities for ABB in water management system. So I will take you through the main agendas and the speakers, and there will be some sessions at the middle I will be in, and also I will take care of the Q&A. You can go to the next slide. Next slide, Mohammed. Yeah. So today, as I mentioned, the main webinar will be about our water management system, water management system in ABB. There will be main insights about this. The main agenda will have to be about introduction to the team, and then we will start talking about the ABB water management systems, the present challenges we have in the market, how to manage operations across the water network, and also the ABB portfolio overview. And then after that, we will take you to another topics for driving the value out of data, mentioning about leakage detection applications, interfaces and architecture, and also about the capabilities for digital twin simulations. Will be also followed by a demonstration video, and then it will end up with a Q&A session. So the main framework for today is most of the participants will be muted. The questions, if has been presented, we will be appreciating if you can put it on the chat during the session. The call duration will be approximately about 60 minutes. And we are going to have some Slido questions and sessions that will be distributed, and then we will expect your feedback on this. Next slide. So today our main speakers will be Mr. Mohammed Abbas. He's our hub sales manager for power and water. He's taking care for the region of India, Middle East, and Africa. And he's also our UAE cluster and head of sales. So our next speaker will be Mr. Gianluca Rondolini, and he's our global product manager for smart water solutions, and also from the same division on energy industries. I think by this, I'm just ending from my side. I'll just give the mic to Mr. Mohammed Abbas to go through that. Gladly to see you, Mohammed, today. So we will just take care of this session. Have a good presentation.
Thank you, Hanan, and thank you everybody from Saudi Arabia for joining this session. It's really an honor and a pleasure to talk to you about a very important topic that's personally close to my heart, which is about water. And I'm really very proud of the fact that, we as ABB have in the last 3 years made a very significant progress from being just an automation vendor in the water space, whether it be water production, water transmission, and water distribution, to really up the ante, and now we can claim that we really offer a complete end-to-end water management system. I'm pretty sure that you will find Gianluca's demonstration and the technical discussion intriguing and interesting for your own operations. I'm just going to speak for another 4 to 5 minutes maximum about why this particular topic is so close to my heart. So if we can transition to the next slide, please. And what I would like you to remember is really 3 numbers from the session today. The 3 numbers are 62, 40, and 6. I'll try and towards the end of my discussion tell you why these numbers are so important to us in the region. Can we have the next slide, please? So the why of the water management system, the big question. And in my view, in a lot of discussions that I have attended with the end users, the key focus for us really is sustainability. And it's not just the water where this particular word is so important. I mean, if you attend any conversation today, whether it's be the circular economy, the net zero, the energy transition, the key word really is sustainability. We have finite resources, and with the population growth and the growth in our economies, we really need to find a way to do more with less. And this is at the very heart of our water management system. The next 2 topics which actually cover the water management system is really the cost aspect. So we want to make sure that we are operating the water network at the lowest possible cost, but balance it with an acceptable amount of risk, really not put the water management system, especially the water network, in any kind of risk while we try to do more with less, which is optimize our cost. The, the big area for cost optimization is pressure management. To me, pressure management, the beauty of this analogy that we have in our human bodies is our own blood pressure. Okay, so we want to really make sure that we are not exerting unnecessary pressure on our heart, on our vessels, and therefore stressing them too much, causing permanent or even a temporary damage, and then balance that with the optimum amount of pressure. Similarly, what we try and do is through our water management system, really make sure that we are operating the network at an optimum pressure, and it achieves two advantages. One, it actually reduces the cost because you're reducing the electrical energy you're using to manage that pressure. We all know that it takes a lot of effort and a lot of energy to transport the water. Similarly, in order to sustain and manage the pressure in a water network, you need to run your drives, your motors, and this also requires electrical energy. So optimum pressure means you're operating the water network at lowest cost. On the risk side, it actually prevents any leakages. Okay, so you're really avoiding leakages as well as you are improving the life of your network, especially the pipe integrity. As I talked about leakage reduction, this is another area which we really are very, very focused on in terms of our water management system. And what leakage reduction does is, again, it's big bucks. It's the reduction of your non-revenue water. If you're avoiding leakage, not only are you saving energy, you're actually saving revenue. You're increasing the potential for your own organization to then generate money through that water, which instead of being wasted is actually going to the end users. From a risk point of view, the biggest risk for leakages is the safety, because any amount of leakage we know is not only water going out of the network but also impurities coming into the network, and that's a big risk, especially if you're talking about potable water. The third area for us is water quality. And what we mean by water quality is that, we all know that in order to maintain a certain amount of quality, we need chemical dosing. So we want to make sure that we are dosing really the right amount of
Assalamu
chemicals.
alaikum.
Wa alaikum salam wa rahmatullah. Was there a question or?
No, I'm greeting you guys. Assalamu alaikum.
Wa alaikum salam wa rahmatullah. Jazakallah. Okay, so we want to make sure that we are really introducing the chemicals at the right points in the network and having the visibility, especially we will talk about it, creating a digital twin of the water network allows us to really monitor what's happening with our water quality and also taking the right decisions. And when it comes to risk, again, we talked about the safety, especially the quality of the potable drinking water. This is what it is all about. I hope that my colleague Gianluca, as he explains, the water management system and our design and our philosophy, you would be able to appreciate how these areas and some of the other areas are actually being addressed through a water management system. As I promised, the three numbers and why these three numbers are worth remembering for us. 62 is the percentage of growth we are going to see in the water demand in the next 3 years, 2025. This is the Middle East region. These are the statistics. Very, very scary numbers. I don't think that there is any other utility service that requires such significant investment in the infrastructure growth as water today. The second number, 40, this is the percentage of water we are losing today to leakages typically. I really hope that the numbers in Saudi are better than 40%, but the world-class utilities are operating that network to below 10%. Singapore, for example, prides itself among some of the other utilities to operating its network below even 3 to 4%. And that's really world class. And I'm pretty sure that we in the region can do much better than what we are doing today. The third and the last number to remember is 6%. And this is the GDP loss that economies in the Middle East could suffer if water scarcity is not addressed. I mean, thank God we have got pretty robust water network. We've got economies which are actually supported by revenues from the oil and gas exports in the Middle East region. We have touch wood been away from severe weathers, wars. So there's not been a lot of disruption to the water distribution and water transmission and water generation in the region. Let's hope and pray that it remains that way. But there is a threat that if the water demand and gaps in the supply and demand interrupt the economy, this is the potential impact. So I just wanted to highlight the significance of this topic for all of us. And that's why we really would urge you to share with us, your problems, especially if they are related to any of the topics we discussed. And, we would be very happy to assist you with your journey as you move from a water automation to a water management situation. I conclude my talk here. Before I hand over to Gianluca, and he takes you through the demo of the water management system. We had a poll. I would request you to please use Slido to answer a very simple question. And the reason is we really want to understand which of the topics are of concerns to you as with regards to the operation of your water network. So
I think I'm just going to share this for everyone. Yep. Thank you, Abbas, so much. It was really smooth and very nice introduction. Really appreciate it. So what we'll do now is we'll be in a Slido session. You can join it by clicking on www.slido.com and then put the hashtag ABB1. Or if you have the application already, you can just scan the code and it will take you directly there. Also, there is a link that has been sent to you in the chat. Just to join it directly and you can go there. So we will start the poll now. So the question is, what are your major challenges while maintaining water distribution networks? Is it descending energy efficiency, increased non-revenue water and leaks, deviation from water quality standards, or maintenance of sensor across the network? So we'll just wait for your interactions and answers.
So Hanan, I've just submitted my response and I'm actually answering this in behalf of a utility that we are working very close here with the Alain Distribution Company. So I hope Alain allows me to respond on their behalf.
Yes, and I think that's great. And I think there is one missing point, which I didn't mention, is about pressure management. But tell me, Abbas, why did you choose for increased non-revenue water and leaks? What's the main reason behind that?
Yeah, I think I probably, I'm more focused on the 40% statistic that I mentioned. Thankfully, there's been a lot of attention from the management of the water distribution companies in UAE towards reducing this non-revenue water. However, what is the fact is that the network is actually growing faster and the demand is growing faster than the investments being made into really the technologies that allow them to identify the leaks. And therefore, what is very, very clear is that there is still over 35% of water which is counted as non-revenue water. And we have been asked to support these utilities in terms of identifying technologies, but not only identifying technologies. I think technologies exist. The challenge is really implementation of these technologies through projects. And hopefully I can just address one more point while we get the results, is that it's not necessary to really do a very large project, a 15, 20, $30 million project and cover the entire network and do the project in one go. We can even plan and implement these projects in smaller chunks, especially when it comes to distribution networks. An example is we are today talking to a lane distribution company who they have 135 district metering areas, and instead of going after the entire 135 DMAs, we are doing a small pilot with them which only covers about 7 to 10 DMAs. So that's less than 7% of the network. And that will allow us to prove the concept, that will allow them to even plan in smaller chunks these implementations. So long answer, but I hope I made the point.
I think that's very clear. Thank you, Abbas. And I think most of the people agree with you that on the main challenges, it's more about descending energy efficiency. Sorry, on increase in revenue and water leaks. Some people went to the other option by descending energy efficiency and deviation from water quality standards. So by this, I think we can just end it here. And I think that we can go ahead now and go to Gianluca and to go through with us actually for the next session.
Thank you, Hanan, and thank you, everybody. I'll be just switching off my video, but I'll be with you throughout the session, and looking forward to an interesting discussion, especially with Gianluca during the demo. Thank you again.
Thank you, Abbas. Thank you so much. And now we're going to you, Gianluca. The mic is with you.
Thank you very much, Hanan. Thank you, Abbas, for the introduction, and I would like to say thank you to all the attendees. I am grateful for this opportunity to explain today to all of you the water management system, and I will just use a couple of slides for introducing the key concept, and then I will go through a live demo. You can interrupt me in any moment if you have any question, any doubt. I kindly ask my colleague, Afan and Anana, to help me if there is also a question in the chat. Just interrupt me and tell me that there is a question, and I will try to answer. If we can go to the next slide, my first slide. Okay. So in order to, let me say, achieve what our colleague Abbas explained us regarding the needs, we need to have a system that is able to allow an operator of a water distribution utility to take the right decision at the right time. And in order to do this, regarding, for example, how to reduce the non-revenue water, how to optimize the energy consumption of pumping station, for example, or how to improve the water quality parameter, you need to do some action into your water distribution network. And in order to decide which is the correct action, you have to collect data, read the data, and analyze data. How to properly collect and harmonize data before taking the right decision is a key concept. And also because the sources of this data may be heterogeneous. Typically from a SCADA, if existing, we can collect some data, but in general, we can have also different kind of sensors that are sending data in different formats. So there is the need of having a layer that is able to collect the data, prepare an intelligent database, what we call the data lake, and add a smart digital layer upon this data lake that will give a simple interface in order to look from the correct perspective or this amount of data, and having the possibility to monitor KPIs, run advanced simulation, and then facilitate the decision that must be taken in order to achieve the objective that we want to obtain. And for example, if you can go kindly to next slide, please. So after the connectivity layer, we want to have a set of feature or modular app that will give the possibility to see the main KPIs into what we call a single view cockpit. And also in terms of functionality, there is the concept of deciding which is the proper functionality that is important for the particular deployment and for the utility that is going to implement such kind of solution. So in some cases, the utility doesn't want to improve all the functionality of the software. In other cases, they want to concentrate on a certain aspect and a certain aspect of the analysis that they need to run. So for this reason, it's also important that any digital layer that you add to your pre-existing infrastructure can be modular, can be scalable according to your needs, scalable horizontally. So for example, starting from a small sector in which we have the digital maturity in terms of sensor and data that are already prepared and harmonized, and then we can upscale the system into the other sector, or in terms of also advanced functionality. If we go to next slide. Thank you. So this can just to add the concept of visibility. Thanks to the digital twin, we can see a complete digital replica of your network. So in order to do some tests, or if you want to upload a network that is similar to the current water distribution network, but with a different layout. If you want to investigate how your current assets, your infrastructure can react if you modify a topology or you add a sector, you can do this with the concept of digital twin. And then you can also calculate the operational KPI or decide which is the best energy efficiency consumption thanks to such kind of tools. So the concept is that some operators, some users will monitor the current status of the network, the current KPI, but there are also some kind of other user that can also run simulation on a future layout of the network or estimate the future evolution of the key parameters of the network. We can go to next slide. This is the look and feel of the single view cockpit. So at the end of this data must be displayed in an interface that should be simple, easy to use and configurable with just some click and without adding some programming code. And so I would switch now to my live demonstration. So I will share now my screen to show you the live demo of the solution. And then if there are any questions now or later, I will be more than happy to try to answer. So if you agree, now I share my screen and I kindly ask to you when you see my screen. If you confirm me that you see my screen.
Yes, John, we can see your screen.
Thank you very much. Any questions so far?
So far, no question for me.
Okay. So what you see here is the user interface. It's a web interface. So
Johnson, can you zoom in? Can you zoom in, please? Little bit.
This way?
Zoom. Yes. Okay, good.
Okay. So this is a web interface. So an important concept is that we want to be able to, the operator doesn't have to install any client. Typically what we do is to install a virtual machine that will be the main server with another virtual machine that will contain the hydraulic tools that are doing the hydraulic simulation of the network. So in terms of software architecture, and I have also some slides later if you have more questions on this. This is a fully owned ABB software that has completely embedded and integrated some hydraulic tool that we have taken from DHI, the Danish Hydraulic Institute. We leverage on DHI for hydraulic modeling and hydraulic engineering knowledge, while as ABB, we have a strong expertise in automation system integration and data collection, and in general, what is everything regarding to interface with the third-party systems, SCADA, and this is a digital layer that we can add upon of course, a pre-existing ABB technology, but also with any third-party technology, thanks to standard interface protocol like OPC or others. What you see here is the initial main interface in which we have a digital dashboard and also a timeline, and everything can be configured starting from the look and feel. So you have the possibility to define the time scale of any trend that you want to visualize, and also in terms of data granularity, this is another important concept. So we can decide to see daily the aggregated daily data, but hourly data per minute, per second, per month, and per year. And this is an initial example on how I can leverage the power of the data lake, the power of the data that I have collected from the SCADA, the historian, on any advanced interface that is already present into the customer infrastructure. So any user connecting with its own username and password will have its own personalized point of view of the water distribution network from analytical point of view. So in the analytics tabs, you can see the current status of the network. And in the simulation tab, you will leverage, as we will see, the full potential of the digital twin. In this moment, we are looking at yes, a digital representation of the network, but reflecting the current reality. You see that this is a demo network divided into 7 districts. We can monitor the network immediately in a nutshell for all zone, or we can decide, to see any particular sector of DMA of the network. And in a nutshell, the user can also look and see the leakage parameter, and immediately, also from a color threshold perspective, see which are the sectors that have more leakage than others. And this is another important concept, how to aggregate data and give an immediate feedback of a district using the data that are collected into the data lake. Then, if you do a zoom of the network, you can see, of course, the details of the water distribution network topology. And again, you see here that there are some colors. The network elements, the pipes, the junction are represented with symbols and also colors. And here you can see all the possible layers of the network. So we can represent device, valves, pumps, pipes, junction, tanks. These are what we call the water distribution network element. And each one can be represented with a color, with a 5-color scale, according to the parameter, again, that I want to monitor. So for example, here, just to give you an initial example, we are monitoring, you see the pipes are represented here with the different colors. And in this moment, the parameter that we see for the pipe is the diameter. So in this moment, according to the predefined threshold, I can see which are the main pipes, and the main pipes starting from this reservoir that is the input of these 7 districts of this demo water distribution network. But for example, if I change this parameter, and for the pipes, instead of the diameter, I want to see a dynamic parameter, like, for example, the leakage, the system will adapt also immediately the representation. You see that now the color of the pipe is changed, because now we are looking from the leakage point of view. So we have a digital asset, a digital represented asset of the network, like a pipe or a junction or a valve or a sensor, that according to which parameter is representing will change also the visual representation. And this is important because we want a system that is able to give also visual feedback of the, and in a nutshell, to be able to immediately evaluate the status of the network. We have a lot of data that we collect every minute from the SCADA, from smart sensor, from IoT sensor. We want to use this data to immediately see the status of the network and to immediately evaluate the KPIs and the main parameters of the network. And you can do this for any item of the network, and for any digital represented asset of the network itself. Okay. Now, of course, the user, there is everything can be configured. So the user has the possibility with the proper rights, of course, to define, for example, the settings, the initial settings for the whole network or for a certain zone of the network, in terms also of leakage parameters. So there is no need also when you are going, let me say, to implement the initial project and the initial status of the network, the initial input is done through a web interface, both in terms of hydraulic parameters, but also in terms of alert settings. So in a visual way, we can define automatic rules. So for leakage hydraulic parameters for any, also for any device. So you can also go to select, for example, if I want an alert about pressure and I want to define also which is the device that is generating a certain alert, and I can also define the timeline and in which, you know, time of the day this alert will reach a certain threshold, and in this case the alert will be automatically generated and displayed here on the left side. So also the concept of helping the user to configure and automate the alert that he wants to receive, because he has the task to analyze a certain portion, a certain, again, point of view of the network, thanks to all the data that we are collecting. Then, of course, there is also the possibility to look more granularly into a certain particular point of the network. So I can select a certain item, for example, a junction or a pipe of the network, and I can look all the data, vertical data in that point. And in this case, I can see static and dynamic metadata of the network. And again, the trend that you see here can be also filtered. So I can decide here to remove elevation and only monitor base demand and unit leak per pipe length in that point, or only, for example, look at one parameter or another one and define the trend, define the time granularity, and do a vertical analysis on that part, and or decide to monitor multiple parameters in that particular point. And if in that point we have also associated a physical sensor that can be present there, and that are represented with these black triangles that you see here, you can check that here, if there is a device, you can also monitor that device that is, in this case, a pressure meter that is going to monitor the status of this parameter. And again, you can represent the trend of this parameter. But this is the case in which I have a physical sensor there. So if there is a physical sensor, I can monitor if there is a pressure flow or a pressure meter or a flow meter. I can monitor that parameter. But if I want to go here in this point, in this pipe or junction in which I do not have any device, physical device, I cannot go into that. I cannot see the hydraulic measurement there, but only which are the parameters that are estimated by the hydraulic modeling in terms of leakage and in terms of water quality. In order to know the pressure or the flow in a certain point in which we do not have any physical sensor associated to that, we need to use the concept of digital twin, as I will display later in this demo. This is what we see here is the main dashboard of the network. Then we have a dedicated dashboard to for hydraulic demand, calculating maximum, average, and minimum hydraulic demand. Again, for the whole water distribution network, but you can also select a dedicated sector of the network, and then you can analyze only a certain DMA or a dedicated sector of the water distribution network. And in any moment, you can also look at the main KPI of the network here. So all the estimated KPI by the system can be displayed here. And again, you can define it for which sector you want to look at it, and also you can do an analysis and also comparison between sectors regarding these KPIs of the network that are used also to estimate the hydraulic balance of each district of the water distribution network. Then we have a dedicated view to leakage. And again, here we can evaluate the leakage parameter every day. The leakage is calculated 1 time per day. So we can see how was the leakage every day, and we can define an automatic threshold that can alert us if a certain sector is having a bad performance in terms of leakage. And also this can be done, of course, for the whole network. And so we can monitor immediately which is the maximum, average, and minimum leakage of the whole water distribution network. And when we switch from one dashboard to another dashboard, we can also, the system is also automatically adjusting here the parameter. Again, you can manually adapt the parameter, but since here I am in the leakage view, the drop-down list is based now on the leakage parameter for each different asset of the water distribution network. So this is done automatically for the user. There is also a dedicated view on water quality. So this is another point of view of the water distribution network that is calculated the estimated water age in terms of hours in which the water is resident into the pipe, for example. And again, we have for each pipe or valve, we have the water age quality, but we can also decide which parameter in terms of substrating concentration or residual chlorine. So these are water quality parameters that again are estimated and digitally represented by the hydraulic modeling tool.
Gianluca, sorry, there is a raised hand for a question from Engineer Abu Flega. If you can go ahead. Yes, please.
Thank you, Mr. Janis, for your session. I have a question here. Is this, can we say that this one is a control system remotely, or this one only for monitoring?
Okay, thank you for your question. This is a very, very important topic. So in order to answer to this question, I would like to, I would like to use a slide to better answer to this. So I should have the slides of today, but I prefer, can you, okay, let me search for one slide, because I would like to share. I have, yesterday I have received the slide, so I will share the slides of today, but I prefer share by myself. Okay, so I will use one slide. Give me 1 minute. Okay. Yeah, this one. Okay, I found it. So I'm sharing again my screen. If you confirm again when you see my screen, thank you. So, do you see my screen again?
Yes, we can see your screen. Okay,
thank you. So you see here the general architecture of the system. So typically, this is a smart digital layer that we install upon a pre-existing control system. So if there is, in some cases, if there is a SCADA or a DCS, This is a system that is for monitoring and implementing the digital twin and calculating simulation, but we take this from a control system. Of course, if the control system is not present or must be updated, ABB has also the offering for SCADA or control system, but in general, as you see here, this is a system that is taking data through an edge from SCADA or smart sensor, but we do not give the data back to the DCS or SCADA. Why? We have implemented the concept, typically the concept of data diode, because for sure, in the initial phase of the deployment of such kind of solution, we do not want to interfere, to break something into the control system if present. We want to read data, monitor data, and create and calculate the KPI from an hydraulic point of view of the network, merging the data that we collect from the control system and the data that are automatically evaluated by an hydraulic model that is running in the backend of this water distribution system. So the WMS is, you see here, the interface, and the WMS is in the middle between the data that we collect from the field and the data that are automatically running in the backend, in the digital twin and the hydraulic modeling. The control system typically is already existing, and we interface with the control system with the standard protocols like OPC UA or DA, for example. We want to give a feedback to the operator regarding which could be the optimal set point to configure in the SCADA in terms of valves position, for example, according to an objective that I want to achieve. For example, if I want to, let me use the concept of energy efficiency. I have also seen from the questionnaire that we have done after the first part that energy efficiency and energy optimization is a key concept that an utility like you is investigated. So in order to do that, we have to define which could be the pressure optimization. And for example, in terms of defining the optimal energy consumption of a pumping station, we have to define what is a pressure zone. So you can imagine here, if we switch back to the demo, that if you have a water distribution network and you want to see here, you see here, instead of leakage zone, you can imagine this as a pressure zone. So instead of evaluating the leakage, we want to evaluate which is the optimal pressure for each sector of the network. But in order to do this, you need, first of all, to be sure that the sensors are properly positioned. So there is an initial evaluation phase that we do together with the customer in order to understand which are the optimal parameters that we want to measure to estimate which is the best pressure for each sector. And we collect this data from the SCADA that typically is pre-existing. If there is the requirement to send automatically back some command to the SCADA, we evaluate this project by project and case by case. Long answer, I hope it was clear. If not, please tell me and I will try to explain better. Thank you.
It's clear, thank you. Huh?
Welcome. Any other question? Help me. I kindly ask my ABB colleagues to help me if there are hands that are raised, please alert me so I will answer. If I do not see a question, sorry, apologies, but help me to understand if there are questions, of course. Thank you. If you think for other questions, in the meantime, I continue my demo. Before switching to the concept of digital twin, let's continue with this example. And here, for example, if you see Here, the user can define, let me say, its own custom interface. Also, here you see that it's easy to build your own digital dashboard. So you can decide that instead of hydraulic leaks and quality, you want to monitor demand or average leakage or minimum leakage or some water quality parameters. So here you build what you want to see in the main interface here in the main dashboard here. So again, this is a key concept. The user want to decide from which point of view they want to monitor the network, and also they can decide to enable or disable some layers of the network. If you want to concentrate your attention, you see, only on the junction distribution of the network. If you are not interested in pipes, you can remove the layer. And this is another key concept here. So we need to start, let me say, from a digital representation of the water distribution network. And this digital representation is typically present in a GIS system. Again, so our three main sources of information are a SCADA or a control system. If it is present, we interface with it through a standard OPC interface. Another important source from which we receive real-time data from the field, from the physical sensor that are present. The second source of information is asynchronous, is one-shot, is the initial digital representation of the network. We are able to import a digital representation of the network using the most standard format for such kind of tools that are EPANET format, SHIP format, GeoJSON format, and BIM format. These are the de facto standard that are used to digitally represent a water distribution network map in terms of georeference of the assets, position of the pipe, all the metadata of these assets, pumping station, valve, pipe junction, something like that. If the user, the utility, has this good starting point, for us, it's easy to export and import here the network map and do the mapping of the text that are currently measuring the data into the network map, and we immediately start the monitoring. If these digital assets are not present, we have the expertise to help the customer to build and reach digital maturity that will be the starting point for implementing such kind of smart layer tools. So we have also the consultancy capability to understand also the optimal trade-off between the number of physical sensors that must be deployed and the related data that must be analyzed. You know, it's impossible to put a physical sensor in any point of the network. So this is why it's important also to evaluate the concept of a digital twin of the network in terms of also not only a static map that digital represent the asset and where they are positioned with their metadata, but also how these assets may evolve in terms of hydraulic parameters. And hydraulic modeling will help to evaluate the status of the network in any point, so the concept of virtual sensor, and also in the future, the concept of what is analysis and the simulation. And in order to see that, we have to switch, you see here, from the analytics tabs to the simulation tabs. If I switch to the simulation tab, initially I do not see anything, because here this is the digital twin and I need to decide which is the aspect that I want to monitor in terms of digital representation of the network. So a new button appears here, and it's the button related to which kind of simulation I want to run. Let's start from the hydraulics simulation. So here you see an initial example of what is a digital twin of the network. This is no more the water distribution network that we have monitored here, you see in the analytics tab, but is the real digital twin. Now, again, this can be done. Remember that this can be done today, in the past. So we can do also historical analysis, and we can decide also how to represent here in terms of trends and data granularity, the status of my water distribution network. Here, now we see that the layers are completely different. This is a digital twin representation that wants to display the pressure parameter in any node of the network and the flow parameter in any link of the network. You see that now the junction are generically nodes and the pipes are generically links. We do not see here pumps, we do not see here, but we see here only a certain point of view of a digital representation of the network. And now I can click in any point of the network and I can see the hydraulic parameter in that point, and I can decide also to represent this parameter. And the pressure here in this point can be monitored now. So step 0 is the current situation. This is like to have a virtual sensor in any point of the network. And this is why this tool can help you to understand which are the most critical part of your network in terms of pressure value, for example, without the need to put a physical sensor there. Of course, we are not telling that you can completely avoid the physical sensor. This is a key aspect. A minimal number of physical sensors is required to do the initial calibration of this hydraulic modeling. The correct number, the proper trade-off between number of physical sensors and digital twin representation is done together by us, our hydraulic expert, and the customer expert, of course, the utility expert. Also because we needed to evaluate with them a set of initial conditions, and we have a set of standard questions that typically we do when we initially discuss a potential project with the customer. If they already have done the division of the network into DMIs, how the districts are implemented, which are the boundaries of the district, and which kind of valves or flow meter we have at the boundaries of the district. If we have a pressure sensor, a pressure meter in the critical part of the network, according also to the geographical topology of the water distribution network. We needed, for example, yep.
Gianluca, sorry, I just have to interrupt you here because we are running out of time. So we need just to go ahead to the second slide of session. The information is amazing and dense, but I think with more technical, we can just have a request from the customers if we can go more technical on this. If you don't mind, if you can just go to the second slide of session, and then we go back to demonstration and then the final QA. Do you want to just say something to conclude this?
No,
actually?
no. Just to conclude, I was concluding my session. If you do, I have a few minutes later to show something else after the slide.
I think yes. I mean, I think let's break this. I mean, actually, and just have
let's break. If I have 2 minutes later, I will just finish. But the presentation is almost finished. Just 2 minutes later to conclude. Thank you.
Yes, sure, no problem. Thank you so much. And then, hello everyone. I think we are going to the second slide of session. This time, I'm going to have another slide of session, which is under the hashtag ABB2. And you can just go through the if you have the applications, you can just scan the QR code. If not, I think you will be posted also for the links, direct links that take you in the website, or you can just click on slido.com and then press the hashtag ABB2. So I'm gonna start the first poll question. So how do you rate the importance of WMS of water management system on water distribution networks? Is it very impactful, moderate, or not useful? So I can see until now it's very impactful. And other people say it's impactful. Okay. Many raising hands. Mm-hmm. So I think about 71% said that it's very impactful, and some people said that it's impactful. So what can I do? What we can do is that just take it in a way that the general perception, it's the importance of water management systems on water distribution networks are really important and impactful. And from this, I'll just take you to the second poll question. Okay, so the second poll question is, are you already using a similar technology on your in your already water networks? Yes or no? No. Okay, could see that there is no similar technology so far that used on the water network. Some of them, they said yes. Okay. So I see that the majority is saying that they don't have a similar technology that is used on their water networks with the same which has been mentioned. I could just go to the second poll question about, would you like ABB to support you on this technology? Yes or no? Wow, good. Yes. So mainly, I mean, we have a major impression that people want, I mean, actually our customers would like to support, would like ABB to support them on this technology. I leave the mic back to you, Gianluca, if you want to, you know, have to comment on this. And one thing also to verify the main conclusion points that you were really speaking about. So you can reshare the presentation, Afan?
Yeah. Okay.
Yes.
Yeah, absolutely. Thank you very much. It was a very, very interesting Slido, and if I can comment it, I'm happy about the feedbacks because it was what I expected in terms of a typical answer that we receive. There is a lot of interest into these new technologies. In some cases, we know that some utilities already have, in some cases, an hydraulic modeling tool or a tool that is looking to such kind of data from a certain modeling perspective. In our opinion, it's important to understand that the hydraulic modeling, it's very, very important, but it's only one aspect, a key aspect, but not the whole aspect. The whole aspect is also how to properly collect the data and how to properly evaluate all the aspects of these potential functionalities. Again, I was commenting regarding how to define the district of the network. The pressure meter, you do not have to avoid at all, for example, a pressure meter, but the pressure meter will be put into a critical point of the network according to an initial evaluation, and that will be used to properly calibrate the hydraulic model. Otherwise, if you do not rely on your data and if you are not sure that the hydraulic model is properly calibrated on that data, you will not trust the result of the tool. For example, I give you a last example. Let's use another kind of simulation, the contaminant event. In this case, you see here that I want to simulate instead of the hydraulic parameter, which is the evolution of a contaminant event, for example, into the initial reservoir of the network, in terms of concentration in nodes and links, in terms of for maximum impact after 6 hours. I want to see after 6 hours which are the part of the network that are most critical. And the tool is able to do this. You see here that, for example, in certain part of the network, after 6 hours, I do not have to make an intervention, but there are these parts that are immediately impacted by a contaminant event. Again, you can do this kind of digital twin simulation if you have a good database, a reliable, database in which you trust your data. And thanks to the data that you trust, you are sure that the hydraulic model is properly calibrated. Also because you can define a threshold for an automated alarm if the parameters that are evaluated by the hydraulic model match or not. If there is a big discrepancy between the data estimated by the hydraulic model and the data measured by the sensor, this can be helpful because this could be an indicator that the sensor needs maintenance because it is sending wrong data, or because the communication between the sensor and the central SCADA is having some communication error. So these are all examples of the potential of data that you could use. Adding such kind of digital layer, adding the proper hydraulic modeling, but combining that with data analysis capability is the key factor to achieve the result that you want to obtain with this digital tool. It's important to have, in my opinion, a partner like ABB that can guide you in all the aspects of this evaluation, from sensor to SCADA and to the smart digital layer like this one. Thank you.
Thank you so much, Gianluca. I think that was really an interesting and a very, very detailed actually information. Thank you for joining us today.
A pleasure. It was a pleasure. Thank you.
Thank you very much. I think that with this, we can just really conclude the session, unless we have any other things to just add up. Anything to add up, Gianluca?
Nothing to add, and except that, again, I would like to say to all of you, thank you for this opportunity to speak to you. Thank you very much.
Thank you. And I want just to thank our customers for joining the session today. And I just want to tell them that if they still have any questions that they need to address, you are most welcome now. And if the time constraint didn't really support us, we can just really take your questions later and then submitted them. The main things just to mention is that also this session is actually recorded, and that we are going to distribute it between everybody who attended today. Also, if you have other colleagues that are not really part of this, has not really been able to participate today, they will be able to be also, actually see it, and we can send them the link for the recording. Main thing also to mention is just, I think that if there is anybody has any more further, clarifications to say, you are most welcome now. Otherwise, we can conclude the session and then just we'll send the main information and thank everyone. Okay.
Thank you very much.
Thank you. Thank you so much. Thank you.
Thank you, guys. I wish all of you a great rest of the day. I will leave now.
You too, brother.
If you have any doubt, please contact my colleagues, and then I will follow up.
Hanan, for your nice talk.
Thank you, Abdullah. Really appreciate it. Thank you.
Just before we end, we just want to give out one message is that let me just add it. This is Arslan. I'm the service sales manager for Saudi Arabia. Just to add here is one thing is that the technology what we have discussed till today till now, this does not really depend on only ABB SCADA system. This is not limited to ABB SCADA system. Irrespective of any type of SCADA system, we can put the water management system and the DHI system. So please take this message as a whole, as a concluding point is that whatever kind of SCADA system you have, we can put the water management system and the DHI system on the top of it. This is for the betterment of the analyzing of your pipelines for your network. So this is the message I would like to make it very clear to everyone. Thank you very much.
Thank you, Arsalan. This is a key concept. Thank you. Correct.
Thank you very much. Anan, unmute yourself, please.
Sorry, I just wanted to say that thanks. I wanted to thank everyone who participated today from our customers, ABB colleagues. And then I just want to repeat that we will send the recordings to everyone. Also, the presentation will be sent to all our customers. And if those who are not really being able to participate today, the link will be sent also that they can also register and also be able to watch the session. Thank you, everyone, and may you have a great day. And I wanted to wish everyone also Ramadan Mubarak. Ramadan is on our fasting session is on the way. So Ramadan Kareem, and wish you all a really great fasting session.
Thank you very much. Thank you everyone
Thank
for
you.
joining.
Thank you, everyone.
Have a good day.
Have a nice
Bye-bye.
Bye. Take care.
Thank you. Thank you, everyone.
Thank you, everybody. Have a great day ahead and Ramadan Kareem.
Ramadan Kareem.
Thank you very much. Assalamu alaikum.